So the topic that we'll start today is states of matter. थोड़ा सा टॉपिक 2022 में और थोड़ा सा ऑल्टर हुआ है, कुछ चीज़ें आई हैं, कुछ चीज़ें नहीं हैं, बट ये वाला जो टॉपिक है आइडियल गैसेस, ये भी थोड़ा कम हो गया। पहले डेविएशंस वगैरह की बात करते थे, अब नहीं करेंगे। So let's start with the topic. What is an ideal gas? So the first state that we are focusing on as per the syllabus sequence is gas, the gaseous state. So what is an ideal gas? No real life gas is an ideal gas. It is just an assumed gas. जैसे in physics you people study different scenarios कि कोई चीज drop की, assume air resistance is zero. But in real life scenarios we know there is hardly a situation where air resistance is zero or where friction is zero. There are hardly any instances. But just for the ease of calculations or for the ease of understanding, we assume such scenarios. So similarly, ideal gas is just an assumed gas. So there are many assumptions of an ideal gas. जैसे gases are made up of molecules which are in constant random motions in straight lines. The molecules behave as rigid spheres. Pressures due to the collisions between the molecules and the wall of the container. ये चीज भी हमारे पास, this is an assumption that we'll be using थोड़ी बहुत, but दूसरे topics में फिर भी तुम लोग ज्यादा करते हो दूसरे subjects में. All collisions between the molecules are perfectly elastic. Momentum physics में तुम लोगों ने पढ़ा elastic collisions क्या होती है, energy is conserved. The temperature of the gas is proportional to the average kinetic energy of the molecules. Again you will study this in detail in A2 physics. अभी हमारा इस पे फोकस नहीं, सारी assumptions हैं ऑफ एन आइडियल गैस के, ये सब assume करते हैं ये नहीं है, उसके अंदर ये नहीं है, this is what it follows, this is what it focuses on, सही है. But the most two key assumptions are for an ideal gas are there are no intermolecular forces between the gas molecules. एक assumption हमने ले ली to make our studies, to make our calculations easier, but we know in real life that is not the case. हमने assume किया कि एक ideal gas में there are no intermolecular forces, the particles are just roaming around just like that, but that is not the case. In real gases, there are some interactions between the molecules, and the strength of those interactions can vary. Those interactions or those forces might be very weak or they might be very strong. The strongest forces that we can encounter is the ion-dipole interaction, or we call it permanent dipole or dipole-dipole interaction. And then there is hydrogen bond, dipole-dipole interaction. The strongest force that we encounter is the ion-dipole interaction, which is in ionic bonding. अब obviously there would hardly be a scenario जिसमें हम कोई ionic bond को बॉइल करेंगे. जैसे सोडियम क्लोराइड मैंने आपको अगर गैसियस स्टेट में ले जाऊं तो उसमें एक सोडियम का आयन है एंड देयर इज अ क्लोराइड आयन. अब उसके बीच में जो फोर्स है वो तो बहुत स्ट्रांग है ऑब्वियसली. दैट इज द स्ट्रॉन्गेस्ट फोर्स बिटवीन टू पार्टिकल्स दैट कैन एग्जिस्ट. उसके बाद देयर इज हाइड्रोजन बॉन्डिंग, देन देयर इज डायपोल इंटरेक्शन, देन देयर इज वैन डर वाल्स डिस्पर्जन फोर्सेस. आवर सिलेबस सेज कि ये जो तीनों हैं, हाइड्रोजन बॉन्डिंग, डायपोल इंटरेक्शन और वैन डर वाल्स फोर्सेस, जो इसमें लिखा हुआ है which is dispersion forces or temporary dipole, all these three are combined and categorized as van der Waals forces. Van der Waals forces is the general intermolecular forces. The ion वाली जो है वो molecules के बीच में होती है, that is between ions. So intermolecular forces, hydrogen bond हो सकती है, which is the strongest intermolecular force. Then there is permanent dipole or dipole-dipole interaction between molecules. And then there is temporary dipole or induced dipole between molecules. ये तीनों मिलाकर categorize होती हैं as van der Waals dispersion or van der Waals forces. Is this clear? तो again ये तो सर हमने assume कर लिया कि कोई force ही नहीं है, but we know in real life there must be some force. Move तो because of the energy that is contained in by the molecules. Molecules के पास जो energy है, so they are just moving at random motions. Right? But force की वजह से वो एक दूसरे के साथ जुड़ती हैं. It is the glue which sticks them together. Now I'll just use a statement: the stronger the glue, the more invalid this assumption is. जितनी stronger इनकी force होती चली जाएगी, उतनी ये assumption हमारी खराब होती जाएगी. सर आपने तो V का सारे पे थोड़ा सा फोर्स है ना. इफ आई टेल यू कि वैन डर वाल्स डिस्पर्जन फोर्स है और आप कहें सर नो फोर्स है, मैं कहूँ हाँ चलो इतनी वीक है, तुमने नो कह दिया. बट इफ आई टेल यू दैट देयर इज हाइड्रोजन बॉन्डिंग प्रेजेंट और अब आप कहें सर नो फोर्स है, नहीं भाई तो इतनी स्ट्रॉन्ग फोर्स है. सो द स्ट्रॉन्गर द फोर्स इज, द मोर इनवैलिड दिस assumption becomes. ये पहली assumption हमने जो देखी, the key assumption, which is that there are no intermolecular forces in an ideal gas. Is this clear? Now, another assumption is that, second assumption, the key assumption है that the volume occupied by the molecules of the gas is entirely negligible relative to the volume of the container. मैं आपसे कहूँ इस कंटेनर में गैस की वॉल्यूम कितनी है, तो यू विल जस्ट यूज द वॉल्यूम ऑफ द कंटेनर. आप कहेंगे सर जो कंटेनर की वॉल्यूम है, नॉट पार्टिकल्स, कंटेनर, जो कंटेनर की पूरी वॉल्यूम है, दैट इज द वॉल्यूम ऑफ द गैस. बट इफ आई कंप्रेस ऑल दीज पार्टिकल्स इनटू वन प्लेस, मेरे कंटेनर की वॉल्यूम तो ये है पूरी, and there is some volume occupied by the molecules themselves. बात समझ आ रही है? दोबारा इसी चीज को, इसी को सबको मिलाकर साथ कर दिया. मैंने कहा ओके नाउ दिस इज द वॉल्यूम ऑफ द कंटेनर, उसमें से कुछ वॉल्यूम है जो पार्टिकल्स themselves भी तो ऑक्यूपाई कर रहे हैं. फॉर assumptions sake we say that ये पार्टिकल्स जो वॉल्यूम ऑक्यूपाई कर रहे हैं ये नेग्लिजिबल है as compared to the volume of the entire container or the volume of the gas. गैस की वॉल्यूम इज द वॉल्यूम ऑफ द कंटेनर. ये बात समझ आई अभी नहीं है? हम कहते हैं अगेन ये assumption भी कब इनवैलिड होने लगती है, जब मॉलिक्यूल का इटसेल्फ साइज बड़ा होने लगता है. फॉर एग्जाम्पल इफ आई टॉक अबाउट हाइड्रोजन मॉलिक्यूल, सर वो बहुत छोटे से हैं मॉलिक्यूल देमसेल्व्स, उसमें कोई मसला नहीं. लेकिन जब मैं क्लोरीन मॉलिक्यूल की बात करूँ, Cl2 का मॉलिक्यूल काफी बड़ा है, तो वहां ये वाली assumption आपकी इनवैलिड होने लगेगी कि सर अब तो मॉलिक्यूल बड़ा हो रहा है तो आप उसका वॉल्यूम तो नेग्लिजिबल कंसिडर कर रहे थे. Remember, ये कोई भी गैस, whatever examples I am using as an ideal gas, none of them are ideal gases. Ideal gas रियल में कोई गैस होती ही नहीं, सही है. बट फॉर assumption sake, फॉर ease sake, आसानी रखने के लिए हम उसको आइडियल गैस कहते हैं. इज दिस क्लियर? गैस लॉज में आपने ओ लेवल फिजिक्स में पढ़ा होगा P1V1 इज इक्वल्स टू P2V2. आप कहते हैं अगर टेम्परेचर कांस्टेंट रहता है तो प्रेशर एंड वॉल्यूम आर इनवर्सली प्रोपोर्शनल, और टेम्परेचर बढ़ाते रहते हैं तो टेम्परेचर इनसे डायरेक्टली प्रोपोर्शनल होता है. Combining all those equations, we end up on this ideal gas equation, which is PV is equal to nRT. P is the pressure, V is the volume, N is the number of moles of gases, R is the molar gas constant, 8.31 it is provided, T is the temperature in kelvins. Now this is a very easy equation to use, but the only thing you need to be worried about when using these equations is the units. This is an ideal gas equation, valid for ideal gases. P is the pressure in pascals. V is the volume in meter cube. Be very careful about this. N is the number of moles. R is the molar gas constant. You don't have to worry about the unit of R at this level. It is 8.31, and T is the temperature in kelvins. This is an ideal gas equation. So this is the ideal gas equation. PV is equals to nRT. इसमें कुछ values हमें देता है and then expects us to find this one. This equation can further be manipulated or used for different values as well. For example, in place of number of moles, if I write mass upon mr, can I do that? Yes. Number of moles is mass in grams upon mr. So this is another form of the same equation that we can have. And similarly, if I write mass, well, remember what is this? Mass in grams, and we are talking about a gas. So if I manipulate this equation, if I divide volume on this side. So can I write this entire thing as mass over volume into RT over MR? And what is mass upon volume? Mass upon volume is density. So the same thing can be used as P is equals to rho RT upon MR, but be very careful. Here the density is in grams per meter cube. Is this clear? So the same equation of PV equals to nRT can be manipulated into different forms and used as per our need. Okay, let's have a look at a question. It's an MCQ. So let's give this one a try. Have a look at this one. First thing you need to do is convert the volume, which is in centimeter cube. The volume must be in meter cube. And 1 meter cube has one, और उसका we use 6 zeros. 1 meter में 100 centimeters होते हैं. So 1 meter cube has 1 and then 6 zeros centimeter cube. Temperature Kelvin, you need the temperature in Kelvin. Yes. Cannot use this equation without having the appropriate unit. That's what I told you. The only thing you need to focus on is the units. So the temperature in Kelvin is achieved when you take temperature in degrees centigrade and add 273 to it. Now let's see. Volume is 7,000 divided by 100,000. Number of moles is found as taking mass in grams divided by MR. Oxygen gas is O2. So the MR is 32. R is 8.31. Temperature is 30 plus 273, which is in kelvins. Now this entire quantity is being multiplied here. It goes on the other side and it divides. And the answer you should end up with is 10.8 kilopascals. Because this is in pascals, the pressure that you get, and once you convert it into kilopascals, because the question is asking the final unit in kilopascals. Is this clear? Okay. Let's have a look at this question. The gas laws can be summarized in the ideal gas equation, P equals to nRT. 0.56 grams of ethene gas, ethene, just for your knowledge, I'm letting you know, it's C2H4, is contained in a vessel at a pressure of 102 kilopascals and a temperature of 30 degrees centigrade. What is the volume of the vessel? So now we need to just figure out the volume. In place of pressure, we can plug in 102 exponent 3 because the pressure has to be in pascals. In place of the number of moles, we can just plug in mass in grams divided by MR. We can figure out the MR of ethene. There are 2 carbons and 4 hydrogens involved. And R has a value 8.31 and the temperature has to be in Kelvin 30 plus 273. So you'll get your volume, which will be in meter cube, but the question has given you the volume in centimeter cube. So you just multiply that by exponent 6 and you get your answer in centimeter cube, which is 494 centimeter cube. 273. I just told you in the previous part as well. And when you have to convert temperature from degree centigrade to Kelvin, you add 273. Whatever the temperature is in degree centigrade, you'll add 273 to that, you will get the temperature in Kelvin. Is clear? In the next question, when an evacuated fluorescent light tube of volume 300 centimeter cube is filled with a gas at 300 Kelvin, now the temperature is already provided in kelvins. Pressure is in kilopascals. You need to convert it into pascals, multiply that by 1000. The mass of the tube increases by 1.02 grams. The gas obeys the ideal gas equation, P equals to nRT. And you need to figure out which gas is this. So you can figure out the MR, you know the mass divided by MR, you don't know the MR. The value of R is 8.31, the temperature is 300 kelvins. Pressure has to be converted into pascals, volume has to be converted into meter cube. You either multiply it by exponent -6 or you just divide the value by exponent 6, same thing. You'll end up getting your MR as 83.9 and the answer is krypton, which is 83.8. Is this clear? Anything that is troubling you till this point? So that is for the basic gaseous state.